Welcome guys. So this is my channel which is I've given the name molecules. So in this under this banner what I will discuss different special topics. Okay. And those topics are related to the your or specific all the topics of chemistry. Part of physical chemistry can be part of inorganic chemistry and it can be part of organic chemistry also. So now last lecture the first video, which was the first video in this channel. So I gave, which was aldol condensation, followed by the Cannizzaro reaction. Okay. Now today the part when now on each individual part, what I will discuss different special topics and special reactions in organic chemistry. Okay. So today, which I am going to discuss is esterification reactions. Is esterification reaction. Okay. So the esterification reaction means a process where you have, let's say, an alcohol, let's say ROH, and you have an acid, let's say RC, R prime, R prime, COH, an acid, carboxylic acid, and in presence of acid which acts as a catalyst in this reaction, what you generate? You generate an ester. Okay, generate an ester and water molecules. Okay, so this is known as the esterification reaction. Okay, so this is the ester. Okay, this is the ester. ESTAR, ester. Okay, ester. Achha. So now this is an alcohol. Okay, and this is an acid, carboxylic acid. So what do you do? So this is a very important reaction, and this reaction is it can be this reaction you will find in chapter alcohol phenol ether and as well as in the chapter carboxylic acid. Okay, in the reactions. Okay, so what I will discuss today is the mechanism how this reaction is forming the ester in presence of acid catalysis. Okay, so let's talk about the mechanism. Okay. Achha. So first, what happens? This is the acid. Okay, this is acid, and this is the carboxylic group. This is the carboxylic group. Okay, so this carboxylic acid. Now we go back to your acid-base chapter. If you have two acids in a medium, so one of the acid will behave as acid, and another which one is a stronger that will behave as an acid, and that acid which is a weaker that will behave as a base. So in between, let's say if this is an acid and you have this acid also, and most cases this acid is given maybe dilute sulfuric acid or maybe hydrochloric acid. Okay. So if I use, so this will behave as a base and this will behave as an acid, and this acid is stronger acid compared to carboxylic acid. So what will happen? The carboxylic acid, okay, the carboxylic acid, what will happen? The carboxylic acid, it will act as a base and it will abstract the proton. Let's say the base is HCl. I am giving, okay. Abstract the proton. So what will happen? This will take place, right? Okay. Now, in this case, in this particular case, what is this? This is a very important now a nucleophilic center. And we know an alcohol, this OH also contains lone pair of electron and it is a very good nucleophile. So what will happen here? ROH, this oxygen will attack in this center and it will open the double bond. Okay. So what will happen in the as the result? So now this carbon is a now its carbon is from sp2 it has become sp3. So this carbon will have, okay, so this is OH, okay, and this is OH R plus, right? and this is my OH, and this is my R prime. Okay. Now, next step, what will happen? This oxygen will abstract this proton, and this will get discharged. So next, C OH2 plus, okay, OR H R prime. Okay. Now here, what will happen next? Next, you have water in the medium, right? So this will act as a base. It will revert back here, and this water, now it is a good living group. Results, C double bonded O, next here O R R prime plus water. Okay, plus water. Okay. Now this is basically plus, here is one water is H3O plus. Okay, and this is nothing but the acid. Okay, this is not nothing but the H plus, right? Okay, hydronium ion. So this is the H plus. So basically what you are getting after the end of the reaction, you are getting the H plus back. Okay, and this is, that's why here the this reaction is known as acid catalyzed. This acid catalyzed esterification reaction between the alcohol and acid. So once again, let me repeat what is happening here in this case, that the acid, carboxylic acid is weaker acid compared to HCl. So the carboxylic acid will abstract the proton, and it will, so it will abstract the proton, and then it will form this OH plus. Now this center, the carbon center, has become a very good nucleophilic site. So this ROH, this alcohol, is a very good nucleophile which will attack in this center and will reopen this. Okay, so now this carbon from sp2, it has become sp3 center. So it is a tetrahedral center. Now see, 2OH and R prime, and this is a ROH plus. Now this OH, this OH present in there. Okay. Acha, one thing I want to mention here. See, I am showing this OH, the double bonded, the two lone pairs is taking this proton and releasing this positive charge. It can happen from this side also. It can happen from this side also. Okay. It's nothing that only that this hydroxyl OH will do that. So this can also do this. This is doing this. Okay. So then it is releasing. Then it has become a OH2. It's a water molecule, and it's a very good living group. And this H is now taken by the external water base. Water acts as a base, takes a proton and reverts back, and the OH2 water molecule releases. So it's finally the ester is formed by, and the byproduct water is formed. Okay, and this H3O plus we get back. This H3O plus is basically the H plus. Okay, that's why, and after the reaction, since we are getting our acid back, that's why this reaction is known as the acid catalyzed esterification reaction. Okay, so that's all. Now see you in the next video.